Imagine this, you run an A B test for your product. Your new feature actually improves conversion by 8%. That is huge. But your data says no statistical significant effect. So you reject idea. You don't launch it. Weeks later, your competitor launches something similar and wins. What went wrong? Was the idea bad? No. Your experiment simply failed to detect something real. And this happens all the time. Companies reject profitable ideas. Researchers overlook meaningful discoveries. Even medical studies can miss treatments that actually work. Not because reality was wrong, but because taste lacks statistical power. And that's exactly what we are going to understand today. Statistical power. Because in data driven decisions, believing something false is dangerous, but missing something real can be just as costly. Welcome back to Sheetal's Data Desk. I'm Sheetal, and in this video, we will break down what statistical power really means, why low power is dangerous, what determines statistical power, the big trade off, why 80% power is common, common mistakes analysts make, power analysis before experiments, and how businesses use power to make smarter decisions. By the end, you won't just understand statistical power, you will understand why bad experiments fail. So, let's start with the core idea. What exactly is statistical power? Statistical power is probability that your test correctly detects real effect when that effect actually exists. In simpler terms, if something real is happening, how likely are you to catch it? Now notice something very important. Statistical power is not about avoiding false alarms. That is type 1 error. Instead, statistical power is about avoiding missed opportunities. That is type 2 error. Let's connect this to what we already know. Type 2 error happens when real effect exists, but you fail to detect it. We call probability of that error beta. So, beta equals to chance of missing something real, which means power equal to 1 minus beta. What does that actually mean? Let's say your study has 80% power. That means if real effect exists, you will detect it 80% of the time. But 20% of the time, you will miss it, even though it is real. That 20% is our beta. Think of it like fishing. If your net has large holes, fish slip through. That is low power. If your net is stronger and tighter, you catch more real fish. That is high power. So, statistical power is basically how good your test is at catching real signals. So, if type 2 error is missing the truth, statistical power is your ability to find it. Now that we know what power is, let's understand why low power can be so dangerous. Low power creates one of the biggest hidden problem in analytics, false confidence. Because when your test says no significant result, most people assume nothing is there. But that may be completely wrong. Sometimes effect exists, but your test was too weak to detect it. This means low power can lead to missed business opportunities, rejected profitable ideas, underestimated treatments, weak product decisions, incorrect scientific conclusions. So, low power doesn't just create bad statistics, it creates bad decisions. Imagine Netflix test new homepage design. Real improvement is plus 3%. That sounds small, but at Netflix scale, that could mean millions. Now imagine they test it with too few users. Result no significant difference. So they cancel it. Reality the feature actually worked. They didn't fail because idea was bad. They failed because their experiment lacked power. Low power doesn't just miss effect, it misses value. So if low power creates bad decisions, what actually determines whether test is powerful or weak? There are four major drivers of power: sample size, effect size, variability, and significance level. First, sample size. This is often your biggest lever. More data means less randomness, better precision. easier detection of small effects. In small sample, noise dominates. In large sample, true patterns become clearer. Think of flipping a coin. 10 flips, randomness can mislead. 1,000 flips, reality becomes obvious. So larger sample size equals to higher power. But more data also means more cost, more time, more resources. So again, power is a trade-off. Second, effect size. This is how big the true impact actually is. If feature improves conversion by 20%, it means it is easy to detect. If it improves by 1%, it means it is much harder. So, bigger effect equals to higher power. Smaller effect equals to lower power. And here's the challenge. In real life, many important effects are small. Third, variability. If your data is highly inconsistent, signal gets buried. If your data is stable, signal stands out. So, high variability equals to lower power. Low variability equals to higher power. Finally, significance level alpha. If you make your significance threshold stricter, type 1 error decreases. But power may also decrease, meaning you reduce false positives but risk increasing false negatives. So, being too cautious can also be costly. Power is not controlled by one thing, it is the result of multiple trade offs. In real life, you cannot maximize everything. You usually cannot have huge sample sizes, low cost, fast decisions, maximum certainty. So, decision making becomes optimization. A startup may prioritize speed. Pharmaceutical trial may prioritize certainty. So, good analysts don't ask what is perfect. They ask what level of power makes sense for this decision. So, with all these trade offs, how do analysts decide what level of power is enough? You will often hear aim for 80% power. Why? Because it means you will detect real effect 80% of the time and miss it 20% of the time. It is not perfect but often practical. So, 80% became balance between reliability, cost, and feasibility. But remember, 80% is a convention, not law. But even with this knowledge, many people still make one major mistake. They obsess over p values, statistical significance, but ignore power. So they think not significant means no effect, which is false because absence of evidence is not evidence of absence. So instead of checking power after failure, one of the smartest thing analysts do is power analysis before collecting data. This answers how much sample size do I need before wasting resources. This matters in A B testing, clinical trials, marketing experiments, product launches, survey design, because prevention is smarter than regret. Now let's connect this to real world because statistical power doesn't just affect statistics, it affects decision. In marketing, a small conversion lift may look insignificant, but at scale, it could mean millions. In product, a subtle UX improvement may seem minor, but low power can cause teams to reject features that actually work. In medicine, a treatment may provide real benefit, but underpowered studies can miss life saving effects. In finance, a strategy may truly outperform, but noisy data can hide real returns. So, across industries, low power can make valuable truth look invisible. And that's the real danger. Good ideas get rejected, real opportunities get missed, important decisions go wrong. Because in real world, missing truth can be expensive. And this leads to the most important takeaway of all. Type 1 error is believing something false. Type 2 error is missing something real. Statistical power is your ability to reduce mistruth. So, power is not about guaranteeing certainty, it is about improving your ability to detect reality. Because in real world, perfect decisions don't exist, but better designed experiments create better trade-offs. If you found this video helpful, don't forget to like, share and subscribe to Shital's Data Desk. Thanks for watching and I'll see you in next video.